Today, our topic is integrating factor. Normally, people just use the conclusion of integrating factor from the work of Joseph-Louis Lagrange. Today, let's discuss how the integrating factor was found. All the things originated from a linear ordinary differential equation of type dy over dx plus px yx equals to qx. We mark it as equation 1, where p and q are given continuous functions, and we want to find out the y function. However, due to px and qx, the equation may not be homogeneous. Even if the equation is homogeneous, we still can separate the variables unless qx equals to 0. Well, we know that separating variables is the most basic solving way. Here, we want to separate variables. Lagrange fought with it for 11 years and finally found that supposing y equals to ux times vx is feasible. We mark it as equation 2. Oh, of course, he didn't know it was feasible at first. He just had a try that substituted the assumption into the equation formula 1. And then we get du over dx times v plus dv over dx times u, which is dy over dx, plus px times u times v. U times v is yx, equals to qx. Then we combine some similar terms and get du over dx times v plus u times dv over dx plus px times v equals to qx. We mark it as equation 3. Lagrange didn't forget his original dream, insisting working on separating the variables. He said, I want to separate u and x. Here's something to notice. Why not separate v and x? Because here v and u are equivalent, but only with different symbols to represent. We can exchange the name v and u or change to any symbol we like. So separating u and x or v and x are the same. Let's keep on track. Lagrange wants to separate u and x. At first sight, if dv over dx plus vx times px times v equals to 0, the whole term u times dv over dx plus px times v disappears. Thus the equation becomes du over dx times v equals to qx. From the left assumption, we can get a v function that follows the change of px, and from the right equation, we can get a u function by integrating it. Since we have both u and v in the expression of px and qx, y is found. Working this way, we essentially get v equals to c1, which is integrating constant, times e to the power of integrating minus px dx, and u equals to 1 over c1 times integrating qx times e to the power of integrate px dx plus c2. Here the question is ended. As we get both v function and u function, we can substitute into equation 2, which is y equals to ux times vx, and get y function. In conclusion, after 11 years of thinking how to separate the variables, Lagrange found that assuming y equals to u times v is feasible. Lagrange found the truth, but he didn't know the truth from the very beginning.